Chasing love.
Okay, guys, chemical equilibrium. Chemical equilibrium. Right? Chemical equilibrium. Chemical equilibrium, yeah? So, what is this topic about? Chemical equilibrium. What is this topic about? It's about the reactions that are happening, right? So, in most cases, we get this stuff. Right? These are what? Reactions, and these are what? Products, right? So, in reality, you get, in most cases, you get this, right? But in reality, what really happens is this. Right? Yeah. Most of the reactions are what? Are reversible, right? Most of the reactions are reversible, right? So what are reversible reactions? That phenomenon is called dynamic equilibrium. So what is dynamic equilibrium? How can we explain the term dynamic equilibrium? So dynamic equilibrium refers to when the forward and the reverse reaction continue to happen simultaneously at the same rate, right? So this is when the forward and the reverse reaction continue to happen simultaneously at the same rate. So this refers to when the forward and the reverse reaction continue to happen simultaneously at the same rate. Right? The forward and the reverse reaction continue to happen simultaneously at the same rate. Right? And we talked about that some reactions are reversible, right? Right? So that is dynamic equilibrium, right? And again, we talked in physics what is a closed system, right? What is a closed system? That's the what? So this is a system where the reaction is isolated from external factors. So this happens in a what? Closed system where there are no what? External factors, right? What about open system? Open system is when there is no what? Where external factors are affecting, right? Where external factors are affecting, that is the what? Open system, right? So as we said that dynamic equilibrium is when the forward and the reverse reaction are continuing to happen at the what? Simultaneously at the same rate, right? So it means that, do you remember when we talked about the rate of chemical reactions in the previous chapter. Do you remember? We said the rate of reaction, we are talking about this dynamic equilibrium, we are talking about the forward direction and the reverse direction are continuing to happen at the same rate and simultaneously, right? So it means that if we're talking about a system like this, maybe let's say we are burning this beaker, right? And maybe there's amount of water here, right? And then we are closing this, right? So this beaker is being heated like this, and then we are closing the system, right? So that when that situation is happening, this is water that is inside, right? Water is what? H2O, right? Right? So when H2O at the beginning of this reaction, right? This forward reaction will be so much like this, right? Can I please erase here? Can I please erase here? So we are having H2O that is reacting like this, right? So when H2O is reacting, what is happening to the system? Well, this is being burnt. It means that this water will turn from being liquid to be what? To be gas, right? So we are going to form the H2O that is gas, right? So when the H2O that is gas is being formed, what is going to happen? What is going to happen? It means that these gases formed are going to meet the what? The lid of this beaker, right? When they meet the lid, what happens to that water vapor? They condense, right? And liquid forms again, right? So when liquid forms again, it means that our new reaction is going to be like this. So liquid into H2O, that is gas, right? What happens now is that the liquids are going to form, but at a lower rate than this, than the gas is forming, right? Can you see that? But the more we keep this happening like this, right? What is going to happen now is the forward and the reverse reaction now will happen simultaneously at the what? At the same rate. So it means that forward and reverse will be the same. Can you see that? Yes. So when that situation happens, what happens now? It means that it's more like in the beaker there's no change. The amount of water will not what? Will not change. Right? So it's not that there's nothing that is happening. A lot is happening inside, but just that the forward direction and the reverse direction are happening at the same time and at the same rate. And we call that dynamic equilibrium. That's when the forward direction and the reverse direction are now continuing to happen at the same rate and at the same pace. Right? So the amount of gas formed is the amount of water formed. You get the point? Yeah, so we can write them like that, other like. Right? So the forward direction and the reverse direction are continuing to happen at the same rate. And if we check, this is a what? Closed system. This is a closed system. So it means that if we change something into this system, it will no longer be the same. If we open the lid, what will happen? Gas will go out. It means that again the forward direction will be more than the reverse direction because there won't be a condensation of water. The gas will go away, right? It will escape. So that is an open system. But if we close now, it is a what? Closed system. We are not allowing anything to go out or come in. Right? So dynamic equilibrium is now reached. The forward direction and the reverse direction will continue to happen at the same rate. Right? So now, this other guy called Licciarella, right? Studied about this and wanted to see what happens if we change the factors that are determining the equilibrium position. Right? Right? Okay. So this is what Licciarella observed, right? He observed that if we make a change to this system, right? If we make a change to this system is happening like this, right? If we make a change, the system will work in such a way as to eliminate the effect or to remove the effect, right? That is what he observed, right? So it means that if we decrease the temperature now, right? It means that the system works in such a way as to bring back the what? The equilibrium, right? Maybe if we decrease the temperature here, what will happen to the forward direction? The forward direction will decrease. So it means that less gas will be formed, right? So if less gas is being formed now, it means that we are having something like this, right? So this is H2O, that is liquid, and this is H2O, that is what? Gas, right? So it means that this has happened now because we decrease the what? The temperature, right? So by decreasing the temperature, it means that the system will work in such a way as to what? To bring back the what? The equilibrium. Because the equilibrium is not this. The equilibrium is this. When the forward and the reverse direction are happening simultaneously at the same rate. So it means that this system, once this water now, that is gas, is condensed enough, it means that it will bring back about the what? The equilibrium, and again the forward direction and the reverse direction will continue to happen at the same rate. So it means that more amount of the what? Of the gas will condense and form the what? Water, right? So if this system, if we increase the temperature above the normal, what will happen? It means that now the forward direction will happen more than the reverse direction. Can you see that? Why? Because there is less gas that is starting to form water, but more gas are being formed, right? And when that situation happens, this system will move in such a way as to cancel that effect, so that we have the forward direction equal to the reverse direction, which we call this the what? The equilibrium, right? So we are going to talk on those factors that affect equilibrium. So there are only 3 factors that affect equilibrium. Can you guess? There's temperature, concentration, surface area, pressure, right? No surface area. No, there is no catalyst. There is just concentration, temperature, and pressure, right? Okay. So now let's talk about these. The factors affecting the what? The factors affecting? So we're talking about factors affecting chemical equilibrium, right? Yes. The only 3. Right? So let's talk about what? Le Chatelier before we can go there, right? So what does Le Chatelier's principle state? Okay, so this is what Le Chatelier says, right? Le Chatelier's principle, right? I don't want it to go there. Oh, that's a great feeling. Okay, I just write like this. So let's see, I'll try to write nicely. So Le Chatelier's principle says this. Don't just claim this, understand what it means, right? So it says that a change in any of the factors that determine equilibrium, right? What are those factors? We say these factors are temperature, pressure, and concentration, right? So it says that a change in any of the factors that determines equilibrium, right? A change in any of the factors that determines equilibrium, right? The system will change in such a way to reduce or to do what? or to counter, right, the effect. That is change, right? Right? So a change in any of the factors that determines the equilibrium will cause the system to change in such a way as to what? To cancel out the what? The effect, or to reduce the effect, or to counteract the what? The effect. Right? That is what the Chatelier's principle states. A change in any of the factors that determine equilibrium. The system will change in such a way to reduce or to counteract the effect change. That is what the Chatelier's principle. Right? So now we are going to go step by step into all those factors to see what happens. Right? So first we will start with the concentration. Right? We'll start with the concentration. Right? Do you still remember when we were talking about the rate of chemical reaction? The rate of chemical reaction. Do you still remember? We said if we add concentration, the reaction will happen faster, right? Do you remember, right? So we are going to use that knowledge and apply it here, right? So, can I erase it? So, as I said, we are going to start with concentration. Okay, so we said now let's talk about concentration, right? So for example, if we're having A plus B giving us C plus D, right? By this we are trying to show that equilibrium is reached, right? Yes. Equilibrium is reached. So if we add A to the system. If we add A to the system, what happens? A is a what? Is it a product or reactant? Reactant, right? So we've added a reactant. So we know that we've added a reactant. So we know that if we add more reactants to the system, it means that what will happen? The system has to use up that A, right? Because there are more A. So it means that the forward direction will be rapid, right? So this is how you answer this. If they say what will happen to this system after adding the reactant and what will happen to the equilibrium position, right? So this is how you answer this, right? Adding A, right? So adding A means that there are more reactants than products, right? So adding A means that there are more reactants than products, right? So according to Le Chatelier, right? According to Le Chatelier, the system has to cancel that effect, right? So the system has to cancel that effect. So to cancel that effect, it means that you must reduce the what? The reactants, right? So it means that the forward direction will be more favored. You get it? So the forward reaction will be more favored. So if the forward reaction will be more favored, what will happen now? More product will form than reactant, right? So it means that more products are going to form than reactants, it means that our equilibrium, yes, shifted right. Does it make sense? So what is happening actually? What is happening is we're in this situation, right? So adding more A, right? Adding the concentration of A, it means that our A plus B now will be more like this. Can you see that? Because we're having more of this. And according to reaction rate, it means that if we add more of this must be used up. So the forward reaction must be more favored. Can you see that? So it means that C plus D will be like this. So if this is the case that is happening, it means that our equilibrium is shifted to the right. So it means that more products are going to be formed than reactants. Does it make sense? Does it make sense? Yes. Yes, the concentration of products are going to increase, right? So that's why I said more products are going to be formed than reactants. More products are going to be formed than reactants, right? So let me repeat this. I said adding A is the what? Is the reactant. It means that if I add A to the system, there are now more reactants than products, right? And according to Le Chatelier, the system must change in such a way as to cancel out the what? The effect. I have to cancel that I have more what? More reactants than products. So to cancel that, it means that the system will move in such a way as to cancel more what? Reactants, right? So it means that by cancelling more reactants, it means that what? The reactants has to be used up, right? So reactants, when they are used up, we are forming more products than reactants. So it means that our equilibrium is shifted right. Does it make sense? Yes. Is it making sense? What's keeping you? So the equilibrium is shifting right. This is what it means. It means that more products are being formed than equilibrium. What is equilibrium? So for this to balance out, right? So it means that more products must form than for it to balance. For it to balance out, it means that more products are being formed than. So for it to get equilibrium, the system itself must cancel out the effects that are needed. Because at first this equation was at equilibrium, right? So adding something, it means that I'm disturbing what is inside, right? So if I add something, I'm disturbing what is inside, right? So it means that the system now will determine like there's a change here, right? So if there's a change, the system must work in such a way to cancel the effect. If I've added more reactants, it means that the system must reduce this reactant. So by reducing this reactant, more products are being formed. Yes. 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 Right? So here we talked about adding the what? The reactant, eh? Yes. So now let's talk about adding the what? The product, right? Let's talk about adding the what? The product. Okay, so let's talk about adding a product, right? For example, if we're adding C or D, right? These are what? These are products, right? So what happens now if we add a product, right? So here now we're talking about adding a product, right? So adding C. What happens if we add C? If we add C, it means that we're having more products than rectangles, right? So adding C means we have more products than reactants. So if we're having more products than reactants, what happens? If we're having more products than reactants, what happens? So it means that according to Le Chatelier, right? Don't leave this guy out in your explanation. Always put this guy in. According to Le Chatelier, right? The system will move in such a way to reduce the effect. Right? What was the effect that was added? Added the what? The product, right? The concentration of the product. So, how will that happen? It means that the reverse reaction will be more favored. So, if the reverse reaction is more favored, it means that more reactants are being formed than product. So it means that now more reactants are being formed than products. And if that happens, if now more reactants are being formed than products, where is the equilibrium? It has shifted left. So it means that our equilibrium shifted left. Yes. Especially yes.
Reduce.
No.
Bob, to reduce.
Such a way to reduce the effect.
Are we clear? So it means that adding the product to the system means that we have more products than reactants, right? So according to Le Chatelier, the system will move in such a way to reduce the effect. The reverse reaction will be more favored and more reactants are formed than products. To reduce the effect. The reverse reaction will be more favored than the reverse reaction will be more favored, so it means that more reactants will be formed than products.
Yeah,
right?
teaching the shoe.
It means that more reactants will be formed than products. Right? Okay. So it means that the equilibrium will be shifted to the left. Okay. So now can I please ask a question? Anyone who would want to answer this?
Yeah.
It can be.
Yeah. Anyone who wants to answer? Ask to come. Ask the question.
Okay, so now I'm going to ask this. What happens if if we remove A, which is a reactant, we remove a reactant, what do you think will happen? Just think about what do you think will happen?
Yeah, the products
Let me see what
will try to.
Anything is fine.
Let's go remove what is. Number is more.
Nami agamara kati kungooneka anga chini. Nende sino nachonga kama
If it becomes called the active change.
Yeah.
So it means that the concentration of C and the concentration of A.
So the program is because the you missed out some of the points, right? So let's see. So if we remove A, right, it means that we have now more product than reactant, right? That is the first point. We have more product than reactant, right? So according to that guy, to Le Chatelier, right? According to Le Chatelier, the system will move in such a way to counteract the effect or to reduce the effect, right? So it means that we have to make up for the removal of this. It means that this has to be 4, right? So it means that the reverse reaction will be favored to reform A, right?
Yeah.
So the reaction, the reverse reaction will be favored to reform this A, right? Right?
Yeah.
So it means that more reactants will be formed than products, right? So it means that our equilibrium is shifted left. Is it making sense now? Is it making sense? So it means that any change that happens, the system is trying to balance out the what? The effect. So if I remove here, it means that we see a seesaw.
Yeah.
Right? So just imagine a seesaw, right? Yeah, that's a good example. Yeah? A seesaw is more like this before we get into anything, right? So if we add children on this side and on this side, 5 on this side and 5 on this side, right? It is balanced if they are having the same weight, at least, right? So if we remove one kid that side, it means that we're having 4 this side. What happens to this system? It will move in such a way as to what? To reduce the what? The effect, right? So it means that it will be like, right? So it means that more what? So I mean it will be like this, right? Because they were having 5 and they were having 4, right? So this system will be more like this, right? To try to balance out the what? The weight, right? So it has shifted that side, right? If you removed right another side, right? But now the only tricky part is that when I that side, I will try to have this kid to go that side so that there will be balance, right? Because the situation will be like this, right? So this will try to rebalance it. So it means that if possible, one kid has to go so that we have 4-4. Right? According to Le Chatelier, it means that this system has to stay balanced.
One kid has to be removed.
Right?
What you are saying is that
So, Louis, let's get this. What about if we remove D in the situation? Can you please come and explain to us what will happen? If we remove D in this situation, in this equilibrium, it depends on which D actually. But
such a nice bar.
If you remove that zero, you are paid.
Kamera yushevile boy. Kamera yushevile boy.
This one.
Come on, what happened?
Can you please discuss? Can you please
Shall we?
yes, can you please start over? Yes.
Meaning that the extent will be more.
Yes.
Yeah.
And then what will happen?
According to
In Chatalia.
Sharia.
The system has to cancel out the effect, right? So it means that now, just because D is removed, it means that the reactions will start going that side. So it means that the forward direction will be favored to form G again, right? And when that happens, it means that the equilibrium shifted to the right. It means that more products are being formed than something like that. Right? So this is
I'm not clear why you go by border. I'm not clear.
okay, so guys, in short, that's what happens with concentration, right? So what's going to happen is this. I'm going to send the question. Hey guys, come on. Guys. I'm going to send I'm going to send questions to the group. I'm going to send questions to the group that deals with concentration, right? And you are going to explain to me what happened. The system, if we're not answering, you're going to have to write what happened, and then I'm going to get that result tomorrow. And then tomorrow I'll continue with temperature and pressure, right? And from there, we'll go to the KC temperature. So guys, let's